Okay, today going to chapter 4, kinetics of particles, impulse and momentum. Reminder, tomorrow is your test one. Tomorrow is your test one. So take note on the time, 8 a.m. to 9:30 a.m. Okay, so this chapter 4 actually is application of what you learned from chapter 1, 2, 3, and then apply for some principle. Then, now today we learn about impulse and momentum. We'll start with the formula that you're very familiar, F equal to M. Right? Then we can recall chapter 1 definition for acceleration, A equal to dv dt. Okay. Then you move the dt to the left hand side. You move the dt to the left hand side, you'll get ft m dv. You know that mass doesn't change, so you pull the m outside, then you put the integration sign because you are having dt one side, dv one side. So you are deriving from f equal to ma. Rewrite the equation into integration f dt and m dv. So if you extend or further develop the integration formula, you will get ft on the left hand side. Left hand side, you get mv. All right. So basically, if you recall what you learned in your physics, left hand side f multiplied by time is called impulse. Right hand side, if you take mass multiplied by velocity, you'll get momentum. Okay, so you change F equal to ma into principle of linear impulse and momentum. So if the question asks you to use principle of linear impulse or momentum, basically left hand side is ft, right hand side is mv. Okay, right. So this is called principle of linear impulse and momentum. So your linear impulse equal to F multiplied by T. This is a change of time, right? Force normally will be, if there is an equation, then you need to put in the equation in terms of T. So you need to be careful on your force here because you're integrating dt, right? So mv here is what you already know. M multiplied by velocity is momentum. Okay. So we simplify the momentum as L, capital L, right? So there are a few capital that we use throughout the module. F for force, U for work, E for kinetic energy, V is your potential energy. Now we have L. L is your momentum. Okay. Basically, you can write them in, right? You can write them out. Okay. So this is to simplify our presentation or our class so that I don't need to keep repeating writing the MV. Right? Okay. Now, this is a linear momentum. Linear momentum means it moves in a straight line. Okay, move in a straight line. Okay, so first part of today lecture is to introduce you how we derive F equal to ma to principle of linear impulse and momentum. Okay, so basically what does it means to you? Means that if you read the question, if the question can solve by F equal to ma, you can solve using principle of impulse and momentum. If you're given time, you're given force, you're given m, you're given velocity, you can solve using principle of work and principle of linear impulse and momentum. Right. So when you see this kind of question, it will be the question will force you to use principle of work and principle of linear impulse and momentum. You will see the similar instruction in tomorrow test one. You'll be forced to use a certain formula. Okay. So this is just a mathematics illustration. If you integrate something, means it's area under the graph. If you integrate something, integrate f dt means y-axis is f, x-axis is dt. Right? You integrate. Same with this one. So if the graph on the top means, if you see a curve, it means that your force is not constant. When force is not constant, it gives you F equal to ma, meaning your acceleration is not constant. When acceleration not constant, you cannot use the 3 Newton motion equation if your force is equation. But if your force is a constant value like what you learn in your statics, then you get a flat graph under the curve. Okay, so that is a different. You learn about impulse in static also, but the force in static is always constant. But when you come to engineering dynamics, your force not necessarily constant. Most of the time, you'll be given a formula. Okay, so there is the difference between statics and dynamics. So you further rewrite. You can stay in the top presentation if the question asks you to use principle of impulse and momentum, or you can write in the second line form, which you consider what happened before equal to what happened after. Meaning momentum before plus the change of impulse equal to the momentum after. Or you can use the first one, same, both are same. It depends on what you want to find or how you write. Okay. Now, when do we usually apply principle of linear impulse and momentum? We are more interested to find the velocity at the end of the incident. Then we use principle of impulse and momentum. Okay. This one you read This one very direct. So if we use a diagram to illustrate the formula, the equation. So mv, you know that mass is a constant, velocity is a vector, right? So m multiplied by vector, vector have direction and magnitude, plus the force and time. Force is a vector, multiplied by time, you get impulse. So then you get the final momentum, mass multiplied by the vector velocity. Okay, so this is just an illustration, right? But what this slide want to tell you is that you are still dealing with vector, and you need to consider the direction of your velocity and force. Okay. All right. Now again, you still need to remind yourself that you have two kinds of motion throughout the module. One is linear motion, which is you have x and y axis. Another one is collinear motion, where you need to use the normal and tangent direction. Okay, and there's a formula to calculate the acceleration in normal and tangent direction. Okay, just take care of that. Right. Okay, then when you solve this kind of question, you can break them into x, y, and z direction. Right. So you solve because this is a bit difficult for you to solve because you vector have direction. So you split them into a non-axis. For example, you split them into a linear motion with its x and y. So you solve, you put all the moment impulse in x direction. You solve for that one. Then you deal with y direction, mv, y, and you do. If the particle move in a three-dimensional, then you add one more z. Okay, this is how you solve the question. Okay. So if you have a sum of bodies, you'll see this diagram when it comes to rigid body. We're now still at particles. When you see a group of bodies together, you just sum them together, right? You just sum them together. This one will come back again, but basically you just sum all the force equal to all the mass and the acceleration of each particles. You still arrive at the same formula, but you add the sum of individual plus sum of individual impulse plus sum of individual impulse. Okay, right. Still the same. Still the same. So today, your take-home homework is to memorize the form of principle of linear impulse and momentum. Okay, so what is impulse? Impulse is F multiplied by time. Momentum is mass multiplied by velocity. So it must be balanced. So the impulse created must be balanced with the change of momentum. Okay, right. So a reminder for your test tomorrow, always give general formula first. Don't straight away substitute because general formula will give you marks. Okay, now when we talk about particles, all our mass will go through center of gravity. So this is just a reminder of how the weight come into the place, right? This one is just a derivation for the individual. So let's see how we apply the same question that you solved for F equal to ma, but now we use principle of linear impulse and momentum. So you look at the question, basically it's a very simple question with a force pull at a certain degree on a flat surface, right? 100-kilogram crane is original at rest. So you have a velocity. On a smooth horizontal surface, you see the word smooth means there is a friction, but friction equal to 0. Okay. If a towing force have a magnitude of 200 Newton acting on the angle 45 degree, apply for 10 seconds. How you know that this is chapter 4, principle of linear impulse and momentum? You will be given time. Right? You will see time in the question. Determine the final velocity at normal force which the surface exerted on the crane during the time interval. Can you draw the free body diagram? The way we solve for engine dynamics question always have a few steps. First, free body diagram. Second, equation, general equation. Third, you substitute or do analysis. Number 4, you conclude what happened. What is the motion? Move to the left, right, up, down, and so on. Okay. So how you draw the free body diagram for this one? Are you able to draw? If you're not able to draw, you're not ready for tomorrow test. This simple question, if you're not able to do, tomorrow is going to be a hard time for you. Okay. So free body diagram, first axis first. Where is positive, where is negative? Right. So move to the right, positive, move up, positive. Then draw the body. Right. Draw the external force. Okay. So the first force we always put in is what? Is what? Weight. Weight go through center of the body. You need to start practicing center of the body. Because when they come to rigid body, you automatic practice that, right? W, or if you forget, if you scared, you forget, just write W equal to mg. Right. Then what else? This body have contact, right? So they have a normal force. And what else? Friction, which direction? Left, huh? F, oh, F, friction. Is right, huh? Friction, huh? But you know this one 0. But still, in your answer, you write F friction equal mu K N equal 0. Okay, important, this one. Okay, all right. Then you split the force into direction that you know. F X F Y. Fx equal to F cos 45, F sine 45. If you're still weak in trigonometry, you need to work hard a little bit, because tomorrow you will see more than 2 angles in tomorrow question. Okay. Okay, so basically this is what the question give you. You are given mass given, time given, velocity before given. What else? You need to determine V2, or just write this one is 1, this one is 2, V1 0, V2 given. Final velocity, normal force. You need to determine the n. Okay, V2, we don't know, and 2. So this question can be solved by F equal to ma, which is chapter 2 equation. It can be solved. Okay, this is the first one. And since the beginning of chapter 4, we know that we can derive this one into principle of linear impulse and momentum. But of course, this kind of question, when it comes to test, you'll be forced to use a certain principle, right? So let's say in this example, we use principle of linear impulse and momentum, which is all the force dt integrate equal the change of momentum mv2 minus mv1. Okay, so remember to put in the limit, t1, t2. Okay, so because we have forces in 2 directions, do 2 set. One is in x direction, one is in y direction. So y direction, all the Fy dt equal to mvy minus mvy1. Okay. So same here. All the force in, sorry, this is x. It's x. This is y. Okay. And when you substitute, you should able to find what is your V2. Here you have Vx1. You find Vx1 equals something, Vx2 equals something. This is vector. We need to find the magnitude of the vector. How to find magnitude of vector? Square root something, square root something, you get the thing. How to find the angle? It depends on the diagram. In this case, very simple. It's a simple diagram. All right. So Vy, Vx tangent inverse. The rest is substitution. Okay. So then you tell where is the direction the object is moving. So basically, this is how you solve it. Oops. Okay, so free body diagram, that's what we explained on the whiteboard. We pull out all the forces, and in this case, we put in the kinetic diagram. In this case, we are more interested in velocity rather than acceleration. So that's why I put V there. Of course, you can put A if you want, but we are going to solve using principle of linear impulse and momentum. We do in principle of impulse and momentum, we do not use acceleration, but we use velocity. So that's why you see the green arrow on the screen there. Okay. If you say, sir, can I put acceleration? Yes, you can. But it doesn't help you in the principle of linear impulse and momentum. You put in the equation, right? Put in the equation. So you can write in this form, or you can write the one that I write on the whiteboard. It's the same meaning. Then you substitute all the value. You get V2, X, and Y. Y, if you substitute also, you will get some value there. All right. So Vy is 0. Vy also 0. So basically, the second equation gives you 0. So you only have one equation to solve. Then you solve for the second one. You substitute the V. Second one, it gives you the N value. Okay. So from here, you can find the friction if the question gives you the friction coefficient. Right. So the question can modify from here. This one can be the part 1. Part B, it will change the scenario. Part B, if you will say if the surface is not smooth and the friction coefficient is given so and so, find the effect of friction on the object. So you ask you to find the effect. So what is the effect? You need to find the velocity. What changes the velocity? What is does it change the time it travel, and so on. Is how you do. So of course, you can solve by using F equal to ma. Means the chapter 2 question, right? Or Newton equation. Okay. In this case, we can use the Newton motion equation because acceleration is constant. Our F is a constant value. So that's why you can use the V equal to VO plus ACT. Okay. Okay. All right. Let's apply the same. Just now it's a flat surface. Example 2 is the same similar procedure. You read your question, then you develop free body diagram. After develop free body diagram, draw the input all the forces, and then predict the motion. Then after that, look at the question. If the question asks you to use certain principle, write the equation. After write the equation, substitute the value, solve in the axis that you need. For example, if linear motion, then normally it's x, y, and z. If you see a curve motion, then normally you need to go to tangent and normal direction. Right. So it is not complicated for engineering dynamics. You usually follow this procedure. Right. The challenging part is you do not have competency in the free body diagram. You miss out some forces there. Right. All right. So this kind of question, you see 25 kilogram crane act upon a force at a variable magnitudes P 100T. So in this case, cannot use the normal, the Newton motion equation because it will make your acceleration not constant. Determine the crane velocity 2 seconds after the P has been applied. The initial velocity is V1. Now V1 is not 0, right? You have a value there down the plane, and coefficient of the friction is given 0.3. So this kind of question also same, derive, draw the free body diagram. Important is your X and Y direction. I would highly recommend you always follow the motion so that your answer or your working will get a positive value. And follow the motion and also follow the surface. All right, in this case, I will choose positive going down so that all my X will be positive and my Y will going up positive. Okay. Of course, you can choose the opposite direction. You'll get negative sign in your solution. Arrive at the same answer. Just that positive, negative sign in your working on it. Okay. So I'll just go very fast for this example. You draw free body diagram, put in all the forces. I need to highlight that if any object that have contact with any surface, you have a normal contact force. Right? Normal contact force will help you to calculate the friction force. Okay. So here, what is the careless mistake usually is your weight. You will confuse with your weight every time you see a slanted surface. Okay, you're confused. Which cause sign that you need to use and so on, right? So at the beginning, highly recommend you put in your axis. Where does you point to? If X is going down positive, then convert your vector like the purple color into Y and X axis. Okay, X axis going here, Y axis for W go down, but positive go up. So once you have this diagram, the next is pull out the equation. All right. Again, this is chapter 4 tutorial question. You can still solve using F equal to MA chapter 2 procedure, but this is chapter 4, so I show you the chapter 4 solution. Okay. So again, start from chapter 4. You see I combine the free body diagram and kinematic diagram or kinetic diagram together. All right. In this case, I put in velocity in the diagram. Okay. So I pull out the principle of linear impulse and momentum. And I split into X and Y axis. Okay. So my X is following the downwards motion. My Y is pointing up perpendicular to the surface. So I split all my forces accordingly. Okay. So I think nothing complex here. It's just a substitution of value. You do the same, you arrive at one equation. If your equation have more than two unknown, don't panic. You're still able to solve. Then go to Y. In this case, you try to find the equivalent of Y, okay, in the diagram. Or you can use the same principle in Y direction. You still manage to find the normal forces. So you substitute inside there, you get your V2. Okay, so this one is chapter 2 solution steps. You can still solve with F equal to MA. Wrong direction. My X direction should be pointing down, not pointing up. Okay, the blue arrow here is wrong, but still able to do it lah. Okay, now in this case, if you use F equal to MA chapter 2 question, all right. Okay, so you find what is your AX, then you use kinematics solution. Why we need to use kinematics? Because your force is not constant. So you freeze your time and then you use the definition of acceleration, dv equal to a dt. You integrate the acceleration, then you get velocity. Yeah. Your tomorrow test 1 will cover up to chapter 3. Yeah. Go and practice something like this. Okay. Right. So yeah. Okay. So the next one example still the same, but this is a pulley system. Now, when you see pulley system, first step, I highly recommend first step you see pulley system, write LT equal what plus what plus what. Calculate the total length first. Then convert total length into velocity between A and B. Convert into acceleration of A and acceleration of B. Try to find when you pull A, what happened to displacement of B. SA and SP. Try to have this information every time you see pulley system. Okay, so when you see this system, 3 kilogram, 5 kilogram. Okay, when you let go 5 kilogram, A will move up or move down? Move up. Okay, so and also SB and 2SA. So when you pull 1 meter SB, what happened to SA? Uh, Again, the question should be, when you pull 1 meter of B, what is the distance moved by A? You pull 1 meter, A move how many? 0.5. Means you move up, SA will move up 0.5. Okay. So this will be the one, and then also if this one move in 10 meter per second, this one will move in 20 meter per second. It moves double the speed. Okay, but different direction, and so on. So again, this formula will tell you the motion between the two bodies. Okay, now once you have this LT equal to something, get VA, VB with A and SASB, then only you go into the normal procedure where you draw the free body diagram. It depends on the question asks you A or B. If the question asks you A, then you focus on A, draw a free body diagram of the body, then proceed with the other procedures like you write the general equation, solve it, and conclude what is the motion. So A, B given. If the system is released from rest, so released from rest, you know that 5 kilogram go down, A go up. And determine velocity of block B in 6 seconds. Look carefully, in 6 seconds is not at 6 seconds. In and at is a different meanings. In chapter 1, 2, 3, you will see at certain time, but when it comes to chapter 4 onwards, you need to read carefully because impulse is F multiplied by time. It's a duration it takes, it give you impulse. So in 6 seconds, you will see that in 6 seconds or in 10 seconds, this one is chapter 4, principle of linear impulse question. Careful, this one is need to be highlighted a little bit because these are the careless mistakes when it comes to assessment. Okay, ignore the mass of the pulley and rod. So this one, you draw free body diagram. Free body diagram. If you see enough example of pulley system, be careful on the datum. Datum will give you the correct positive direction. In this case, SB go down positive, SA go down go positive. And also, datum will affect your potential energy. If the question change to use the conservation of energy, you can solve this question with conservation of energy. So just be careful when you see datum will affect your potential energy if the question asks you to use energy principle. So then the pulley system, after you do this one, normally you need to find the force on the rope. So in this case, this one will give you tension, and then this one half a tension of or this one is T, this one will give you T lah. So this one is 2T, this one is T, this one is T. So for the pulley B, sorry, not B. So I believe you know the meaning of this diagram. So if you see the pulley B, tension pulling down is 2T, and this one is TB, TB. So you have 2TB, and so on. Okay. Then you draw the free body diagram for A, draw free body diagram for B. The careless mistakes usually is the tension in the cable, or even you don't know to use this diagram. Okay, be careful on the tension cable. It will not be the same if you have a few pulley there. So for object A, you have 2 TB. For object B, you have 1 TB, and the weight of each of the object. Okay, so when you have this one, okay, then here also I include the velocity. I include the kinetic diagram on the same free body diagram. Okay. So again, I show you how to find the velocity, relative velocity between the two bodies. Right. So this one you should be familiar already for the pulley system. Then we use the principle of momentum. We look at block A first. So principle of linear momentum, you focus on the object. Each object have one equation. So here you have two objects, you have two equations. So each one will give you one equation. You substitute the value inside there. Then you go to first equation, you're unable to solve because you have two unknown, TB and VA. Do for B, you apply the principle of linear impulse and momentum. Okay. Now, why VB 0? Start from rest. Okay. Then you substitute the impulse. Impulse is F multiplied by time. As long as your free body diagram have force, each force will give you impulse. So you have one set impulse here, one set impulse here. That's why you see TB have one impulse, the weight have one impulse. Yeah. So you have two equations solving simultaneous equation. Okay. Solving, you find VB and TB. Okay. Now, every time we learn about principle, there will be a formula called conservative or conservation of something, right? Now, when you do conservation of moment and system, you need to know, again, you need to differentiate what is conservation, what is conservative, right? Very simple is if the friction is not there, normally it's conservation. Okay. Why friction is not conservation? Go back to the chapter 3 recording or PowerPoint slides. Okay. So this is just a formula or principle of linear impulse and momentum. So when we have sum of external impulse acting on system particles is 0, the system become conservative. Okay. Means no impulse acting on the object, then it become conservation of momentum, conservation of linear momentum. So if the question mentioned use conservation of linear momentum, it just means that momentum before equal to momentum after. You're looking at the momentum. Okay. Now conservation of energy, it means all the energy equal to before equal to after. So energy will need equal to momentum after. Okay. Right. So right, if the question, usually this is the second part or third part of the question. Something. So if the question asks you use linear conservation or linear momentum, write this. All the sum of MB1 equal to sum of MB2. Okay, in this case, because this is sum of individual particles inside the system, for rigid body, for particles, we straight away we know that all the mass go through center of gravity. Okay, so this formula you see it when you learn in next chapter where we start to look at rigid body. It is combination of lots of parts like bodies. Your head have weight, center of mass for your head, body, hands, and your leg. So you need to combine each of the bodies become one. Okay, so this one is another application of conservation of momentum. So you have two bodies there. Okay, so you have box red color A and another tank B. Both move in the same direction, different direction. One move in 1.5 to the B and 0.75 towards A. So each one give you the weight, the mass in megagram. Remember to change them into unit SI, which is in kilogram. So one of the careless mistakes also here, when you see megagram, you don't know how to change to kilogram. Okay, so change 15 megagram into 10 power negative 10 power 3 kilogram. All right, so it's costing and so horizontal track. So horizontal track means it's a linear motion. You're dealing with X and Y. When you encounter so and so, if car collides and coupled together, coupled means joined together. All right. So determine the speed of both car after coupling and average force between them if coupling take place in 0 per second. Now, if you see this kind of motion, straight away is under principle of momentum. Okay, principle of momentum means before equal to after. Okay, so you write this one, this equation. Then you look at the question. Because here, it do not give you force. So don't go and squeeze your brain. Go and add the impulse there. The force is not, the weight is given. There's no force in the diagram. Right? So when you see this kind of things join together or split, collide one means hit each other, then bounce back or something. So when there's two bodies hitting each other, is under momentum question. Okay, momentum. So before you have two bodies. After join together become one body. So you change your equation, m1v1 plus m2v1. Sorry, this is maybe you write. This is A, this is B. So MAVA1, MBB1 means before, equal, when they join together, MA plus MB. When they join together, they move in the same speed. So V2. Okay. Now, what happens if this is separate? Separate. I jump a little bit from this question. If it's like a snorkel, you hit and it's bound. Same. If it's split, then same. M, let's say this is A, this is B. MAVA2 plus MBVB2. Okay. Again, you're dealing with vector. Vector have direction and magnitude. Always give direction where it's positive, where it's negative. If it's bounce back, need to see where's the direction. If VA is bounce back to the left and your positive direction to the right positive, your VA will be negative. VA2 will be negative. VB will continue to have positive and so on. Same with this one. If A go this way, B go this way, VB will give you negative VB. Although the equation is plus, but it still give you the negative value. Negative momentum. Yeah, I hope you get the principle or the idea. Once you understand this one, you can do most of the question already. Okay. So important is to look at the question and try to identify if it join together or bounce or hit together on the same line, then it becomes momentum question already. Before, go to after. Okay. So if you understand what does it means and what I write on the whiteboard, it basically is what you see on the diagram here. So if two car coupled, right? So F will move to the left, F will move to the right. Momentum is conserved in X direction. So because it's happened in the center, they join together means the force was happened inside the bodies. We are not interested to look at what happened inside the bodies. It's called internal impulse. We're not interested. We look at the whole system. So here that's why we take out the FT. Okay, we take out the FT. So we have the conservation of linear momentum. So MB1, MB2, MB1, A, MBB1 equal to MB2. MA plus MB because they join together. If they split, then you need to split MA V 2 MB V2. Okay. Okay. So you substitute all the value. You only have one unknown, which is V2. Okay. So you solve by V2. Again, you need to give the direction. The answer, if you get a positive value, it means you follow your reference axis. If you get a positive value, positive axis is moved to the right, is positive. Then the motion, the velocity will be to the right. Okay. So start have a habit to tell the examiner where is the direction. After you solve it, explain what happened to that body. Does it move to the left? Does it stop? Does it go anywhere? What is the angle? What is the vector? Okay. So part B, right? So A is the speed of both cars just after the coupling, and B average force between them if the coupling take place in 0.8 seconds. You see the word in means duration of time. Duration of time means, I have to use the impulse equation already. So there's only one principle in chapter 4, which is principle of impulse and momentum. So write the linear impulse and momentum equation, substitute the value. So here, again, principle of impulse momentum, you only apply to individual bodies. You don't join the two bodies. Every time you use principle of impulse momentum, you look at the bodies, individuals' bodies. One set for one bodies, because each body have different momentum. So you do the same, you apply the equation. The one that we don't know is the force. Okay. Because the previous section already give you the answer. And even they give you, yeah, okay. So you substitute, you get your force average, right? Okay, we do one more, then we call it a day, huh? Now this is a bumper car. So again, when you see two body hit each other, either is join or is bounce back, it's still a momentum question. It depends on whether it's asked you to find FT or not. How you know you need to find FT when you are seeing in 10 seconds, in 2 seconds, so on. If you didn't see it, then it's just a simple conservation of momentum. Okay, so bumper A car, they have mass so and so, coated with velocity shown before they freely collide head on. If no energy is lost, no energy resource is lost also mean conservation of energy. Here, conservation of energy. No energy is lost. It means ask you the energy. During collision, determine the velocity after collision. So you're given A and B velocity. Again, have a reference axis go to the left positive, going to the right positive, going up positive. So free body diagram A, B, and remember the contact force. Okay, the rest you already understand already. Only need to highlight the contact force. When it comes to after chapter 3, chapter 4, 5, 6, 7, 8, you might forget the normal cost, the normal contact force. So always remember there's a contact surface, they always have a normal force. Remember that. Okay. So the force of each other will be different. Okay. So which one is which one? You should able to differentiate. The red arrow force is the right hand side is A. The left hand side is B. Again, how you know? Imagine yourself, you are the object, and what do you feel? If you are A, you hit with B, what do you feel? You feel something hit you in the body, right? The force is going in your body. So for A, the blue body here, the right hand force is pressing the A. Yeah. So you do conservation of momentum. Momentum before equal to momentum after. In this case, we split the two of them because they do not join or they do not say that they coupled together, right? So you split the mass into two bodies, individual bodies, and you substitute the value. In this case, you are looking at x direction or flat direction. Okay. You find there's a VA and VB. Here, you stop at here, you are unable to solve what is your A and B. All right. You need one more equation. Okay. When you meet this, when you use conservation momentum, you arrive at one unknown equation with two unknown. You know that you need one more equation, but you read back the question, actually give you hints. No energy is lost. He give you hints that there's a conservation of energies equation you need to use. Okay, so these are hints lah. So a concept of energy, so kinetic and potential before equal to kinetic after, potential after. In this case, there's no change of datum, there's no change of height. So potential cancel. Just draw an arrow zero for the potential. So you're only comparing kinetic before and after. Okay. So kinetic here, you have two bodies. Each body will give you one kinetic energy. A have its kinetic, B have its kinetic. So you see here the working is A before, B before equal to A after, B after. And I put 0 in the solution. Okay. Substitute, you'll get a quadratic equation. VA, VB, VA square, VB square. You substitute this one in, you'll find what is VA and VB. The rest is mathematics. It's not related to the engineering dynamics. Okay, so the concept for today is the principle of impulse and momentum. What is impulse? Impulse is force multiplied by time, or its momentum, mv, mass multiplied by velocity. And then how they collide, how they join together, or how they behave after the incidents, it depends whether they join or split. Okay. Okay. Then I also show you when you have a quadratic equation, there's two roots. You need to wisely choose which one and which one. In this case, 3 and minus 2. And you say that the general direction to the right is positive. So VB to the left, when it bang together, or when it's bang, VB will move back, right? So because the speed also a bit higher, A will be higher. So normal logic thinking, B will be moved to the right. Okay. So we choose the minus 2 and not the positive 3. Positive 3, positive 3 means it continue to move to the left hand side. Sorry. Yeah. Sorry. BB before, just before the collision. Okay. Yeah. Okay. So you can see VB is 3 minus 2 in the diagram. 2 to the left is minus 2. So the another answer is 3. Understand, right? This is a quadratic equation. So you have two roots. One is 3 and minus 2. So before you look at the diagram, this before it happened is minus 2. So another answer is after is 3. Yeah. Meaning, if you look at this solution, VB have two answers. Meaning it's a quadratic. So VB at this location, when it hit and after, it will bounce back at the same location. So they have two velocities. Yeah. Okay. So we stop at example 5. Right. See you tomorrow, 8 a.m. and meeting room number 2. Yes.